Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we begin our journey in trigonometry. So trigonometry still involves triangles, but we're going to restrict our attention to right-angled triangles. And trigonometry only works because of similar triangles. So let's look at this diagram here. So we have a smaller triangle and a larger triangle. These two triangles are similar. They both have a right angle, and they both have this angle, which I've called theta. That's just a Greek letter there. So two pairs of equal angles. This is equal in both triangles. This is equal to. That means they're similar by the AAA test. So I'm going to label some sides now. So I'm going to call this big O, little o, big A here, and then little a will be this side here, okay? So sorry about calling them O, especially. That'll become clear later in the video why I did that. So because of similar triangles, the two triangles are similar, that means sides are in the same proportion. So these two sides correspond to each other. So big O over little o is equal to big A over little a. That's what it means for the sides to be in the same proportion or have the same scale factor. Now, with a bit of algebra, I can rearrange this. This actually means big O over big A is equal to little o over little a. So actually, what similarity means is not only are sides in different triangles in the same proportion, sides within the same triangle are in the same proportion. The ratio of this side and this side will be exactly the same as the ratio of this side and this side. So this has a very special name. This is called the tangent or the tan ratio. It's the ratio of O to A. So why did I choose O and A? So when we're labeling sides in trigonometry, we label the sides as O, A, or H, and they refer to an angle here, theta, not the right angle. So O is the side that is opposite theta. So opposite means facing. So this is the side opposite theta in the small triangle, and this is the side opposite or facing theta in the large triangle. So A means adjacent or next to. So this side is the one adjacent or next to theta in the big triangle, and little a is the one adjacent to theta in the small triangle. Of course, this side over here is the hypotenuse. This is the hypotenuse of the smaller triangle, and the hypotenuse of the larger triangle is this side here. So you know the word hypotenuse. We went through that when we talked about Pythagoras, and then again in the RHS test. So the hypotenuse never changes. It's always the side facing the right angle. So an interesting point in any triangle, the longest side always faces the largest angle, and the shorter side always faces or is opposite the smallest angle. So what were we doing over here? Well, what we're saying is if I know what this angle is, this ratio, O over A, is fixed. So for example, if I know that theta is 45 degrees, the ratio of O to A is 1. That means they're the same length. It turns out if, say, theta is equal to 30 degrees, the tan of that, tan of 30, is about 0.58. So that means if this angle here were 30 degrees, this side here would be about 58% of this side here. It turns out if theta is about 63 degrees, then that ratio, the tan ratio of 63 degrees, is approximately 2. If this angle was 63 degrees or thereabouts, then this side here would be double this side here. So we're going to investigate the three ratios you need to know in this video, and then later we can use them to find unknown sides and angles. So for example, if I know that this is 63 degrees and I know that this side's 10, this side would be 5. Because if this is 63 degrees, the opposite side is double the adjacent side. That's where we're heading with this. But let's go through the other 2 trigonometric ratios. So there are 3 ratios that you need to know. Sine ratio, abbreviated sin, the cosine ratio, abbreviated cos, and the tangent ratio, abbreviated tan. This is the one we looked at on the previous slide. So to know what they actually are, what the ratios are, this is the acronym you need to know, Sohcahtoa. Sine is the ratio of opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So we just have to get used to using these ratios. So this is the kind of question we would be going through in this lesson. So let's say we have this right-angled triangle here. So we have an unknown angle here marked theta. So the value of sine theta is opposite over hypotenuse. So opposite is the one facing it. Hypotenuse is the one facing the right angle, the longer side. So sine theta in this triangle is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. So it's the adjacent side, the side next to theta, over the hypotenuse. So it's 12 over 13. Tan theta is opposite over adjacent. So make sure you can label all of the sides as well as find the ratios sine theta, cos theta, and tan theta. So now we're just going to do a question that's slightly harder. So sine theta is 35 over 37. What is cos theta? So if you're asked for sine theta, cos theta, or tan theta, your answer should be a fraction like this. It's a ratio. So let's draw a triangle for which sine theta equals 35 over 37. So we have a situation like this. So we'll call this angle theta. So sine is opposite over hypotenuse. So the side opposite this, which is this one here, would be 35, and hypotenuse is on the bottom. That will be 37. Remember, hypotenuse is always opposite the right angle. So we need to find cos theta. So to find cos theta, we need to know the adjacent, because cos is adjacent over hypotenuse. So we can actually figure out this side using Pythagoras. So it's a shorter side, so we minus. So it would be the square root of 37 squared minus 35 squared, which is actually equal to 12. This side here, the adjacent, would be 12. Cos theta would be adjacent over hypotenuse. And of course, in this case, tan theta would be 35 over 12. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.